Hello everyone, once again welcome to PM Networking. Guys, today in this video we are going to configure this network. As you can see over here, this is my network. These are my access user, right? These users should be able to access internet 8.8.8.8, and you can see we have two connectivity from ISP. This is my primary link and this is my secondary link, right? I have two connectivity, one from Airtel and one from Tata. So we will configure multiple protocol in this topology. Here to define this link as primary link, this link as secondary link, we will configure IP SLA, right? On my edge router we will configure PAT, port address translation, right? So that these user can access internet with the help of private IP address. Fine. Here we will configure IGP protocol, maybe Eigrp, or you can configure OSPF, any IGP protocol for reachability. Fine. Here we will configure Hsrp for first hop redundancy, right? So we will create virtual default gateway, and that virtual default gateway we will define to this PC. Fine. Okay, let me remove these two PC from here. Today we will not consider these two PC. Okay, suppose this is my network. So guys, this video will cover so many interview question as well. Many time interviewers asking to network engineer, if you have two connectivity from ISP and we have one router and three switches, how you will design network, what protocol you will run, how you will define primary and secondary, so that when primary will goes down, secondary will be in active state. When a secondary will goes down, again when primary will come up, again my traffic should go via primary link, right? So we will configure each and everything. This video is based on real environment, so this video will cover so many interview question as well. So if you want to get 100%, please watch this video till the end. If you will watch this video till the end, then only you will get 100%. So we are going to configure multiple things in this topology, okay, multiple protocols. So first of all, let me describe this topology to you. As you can see over here, we have two connectivity from ISP, and this is my edge router. I have only one router in my company, and we have three switches. So if someone will ask you, if you have three switch and one router and two connectivity from ISP, how you will design network? So guys, first step is we have to all switch together, right? Or you can use multiple link between switches as well. Fine. This is stacking, switch stacking. After that, you need to connect any two switch from these three switch to router. Suppose this is my router, right? These are three switches, so you can connect any two of them to router like this, okay? And we have connectivity from ISP, two connectivity, so you can connect this link to this router, and here you can connect your access user and devices, right? Maybe server, maybe PC, whatever devices you want to connect in your local area network. This is your LAN. Here we need to configure IP SLA, right? After that, here on this router we need to configure PAT, right? Here we need to configure Hsrp, so that if my primary link is up, so whenever these user want to access internet, all traffic will go via primary link, right, through Airtel. But when this ISP will goes down, or if this link will goes down, automatically my traffic will shift on this link. Automatically my traffic should shift on secondary link, right? And again when primary link will come up, automatically my traffic should be shift on primary link, right? So we will configure these all things in this video. After that, second requirement is, so here you can see this is core layer, this is distribution layer, this one is core layer, distribution layer, okay, distribution layer. So we have two default gateway, this one and this one. So if you will configure the IP address of this interface as default gateway to this user, and if this device will goes down, or if this link will goes down, or if this link will goes down, right, these user can't access internet. So we need virtual gateway, right? We need virtual gateway. So when this switch will goes down, or this link will goes down, or this link will goes down, my traffic should go through switch 2 to core router, and core router to primary link. If primary link is down, then my traffic should go through secondary link, right? But again, when this switch will come up, my traffic should shift on primary default gateway, right, like this. And again, if ISP is down, then my core router will shift my traffic on secondary link. Fine. So these are my requirement. Okay, so let's start configuration from ISP router. I will not configure anything on ISP router, right? Only I will configure IP address. Okay, so I have access of all these switch in secure CRT. Okay guys, so as you can see over here, I have access of all devices. So this is my edge router, this is my switch 1, this is switch 2, this is switch ISP router 1, ISP router 2, PC1, PC2. Okay, so first of all, let me show you IP configuration. IP interface brief exclude unassign. You can see I am running 11.1 on serial 2/1. I am running 22.1 on 2/1, and I am running this IP address on Ethernet 0/3/0, and on 3/1 I am running 10.5. Okay, so ISP router, this is ISP, so IP interface brief exclude unassign. So let me create one loopback. Okay, no, this one is ISP, na? Yes. So IP interface brief exclude unassign. This is my ISP 1. You can see the IP configuration of ISP router. So on ISP side I am running 11.2. On ISP 2, so IP interface brief exclude unassign. On ISP 2 I am running 22.2. So IP configuration of ISP 1 and ISP 2 is fine. Now let me check IP configuration on switch 1. So IP interface brief exclude unassign. Okay, so on Ethernet 0/2 IP address is this one, fine. And let me configure IP on Ethernet 0/1 as well. Interface Ethernet 0/1, no switch port. IP address will be 192.168.10.10. Here I will configure 10.10. On switch 2 I will configure 10.20. Okay, and with the help of Hsrp we will create virtual IP that will be 10.100. Okay, so IP interface brief exclude unassign. Okay, so go to switch 2, configure terminal, interface E0/1, no switch port, and IP address 192.168.10.10.20, 255.255.255.0, exit. So IP interface brief and exclude unassign. You can see. Okay, so IP configuration of all devices is done. Let me configure IP on PC as well. IP 192.168.10.1/24, and default gateway will be 192.168.10. If I will configure default gateway 10.10 here, so all traffic of this user will go via switch 1 only. So I am configuring 10.100. So we will create this IP address. This is a virtual IP address with the help of Hsrp. Okay, IP 192.168.10.2/24, and default gateway will be 192.168.10.100. Fine. Now Here we need to configure default routes towards ISP, right? So we will configure default route through track, and I will configure one default route through track and one default route with AD value, with a different AD value, not default AD value. Okay, so first of all we will create one track. After that track object, you need to define one number between this range. Okay, so this is my track number. After that IP and SLA. Why I am creating track for IP SLA? I want to use this track with IP SLA. After that LSA entry number. So when you will configure SLA, right, you have to define one entry number. So suppose entry number is 10, right? And after that, if you will put question mark, you can see command is fine. Right now we need to create one SLA. So IP SLA, after that number, you can see entry number was what, 10, and till here. Then ICMP echo, if you will put question mark. So which IP address do you want to ping through IP SLA? You can ping 8.8.8 also, or I want to ping my public IP address which is running on Isp Router, so 11.1.1.2. okay, and you can define source as well. If you will not define source, then source will be your exit interface. Okay, after that you can define frequency is 10. So IP SLA is done, and let me start IP SLA. So IP SLA schedule number is 10, and when you want to start this IP SLA, means start time is now. I want to start now, and till when you want to run IP SLA? For lifetime, for forever. Okay, so SLA IP SLA configuration is done. You can verify. So IP SLA, you can run this command. So track, see my track state is up. So now router 1 is pinging to 11.1.1.2. fine. Now we need to configure default route. So IP route 0.0.0 0.0.0, and next hop will be 11.1.1.2, and use track 10. And let me create one more default route here, that will be 0.0 0.0.0, and next hop will be 22.1.1.2. guys, I am not going to discuss what is LSA, how LSA work, what is track, how track work. These things I already discussed in theory class, right? This is configuration video. In this video I will configure only. I will not discuss what is route map, how route map work, what is ACL, NAT, PAT. No. Here I am going to configure only. Okay. And AD value will be 10. If you will put question mark over here, you can see distance. So distance is 10. So how many default route are there? So IP, or you can run, so run section 0.0.0. So you can see in running configuration there are two default route, but in routing table, so IP route section 0.0.0. In routing table you can see there is only one route, reachable via 11.1.1.2. So if ISP1 bill goes down, let me down ISP1 interface serial 2/0. Let me run no shutdown command and see guys what will happen. This next hop IP address will be automatically modified after some time. Yes, now you can see next hop is what, 22.1.1.2. okay, so with the help of SLA we can achieve it, right? Okay, now let me run no shut again, no shut, and now you will see after few seconds it will modify next hop IP address. You can see now just wait. Yes, next hop is what? 11.1.1.2. So automatically when ISP will goes down, router will shift your traffic on secondary link, and again when primary link will come up, your edge router will shift all your traffic to on primary link. Fine. So if I will ping 8.8.8.8, yes, I am able to ping. If I will trace route 8.8.8, you can see my all traffic is going through 11.2. Let me set this interface once again, and if I will ping now, so it will take some time, few time. This is timer. You can manipulate these things in real time as well, right? We can change timer, we can change frequency. Okay, just wait. Yes, now you can ping, right? And if you will trace route now, you can see next hop is what? 22.1.1.2. Now let me run no set command on ISP1. So automatically router 1 edge router will shift your traffic on primary link. Fine. Now we need to create PAT, because I am able to ping 8.8.8, but am I able to ping 8.8.8 from my LAN interface from Ethernet 3/0 from Ethernet source? Source is this one. No, I am not able to ping 8.8.8 from LAN interface. So here we need to configure PAT, right? That will translate private into public and public into private. So we will configure PAT, and we need failover as well, right? Because when primary link will goes down, my traffic will shift on secondary link. So we will configure PAT with the help of route map, right? With the help of route map and ACL as well. So first of all, let me configure access list 10, access list 10 permit any. Fine, any permit any. After that, route map, and name of route map is suppose this is my primary link. Okay, and then sequence number is suppose 10, and match what we need to match in route map. You have to match interface and match from access list. So match interface serial 2/0. This is primary. I am creating route map for primary link now, and match IP address. Match IP address from where? From list 10, right? So let me create one more route map here. Route map and secondary sequence number is suppose 20. Clear. Match interface serial 2/1. This is my secondary link, and match IP address from access list 10. Fine. Now we need to configure PAT. So first of all, let me configure inside and outside. So interface serial 2/0 is IPNet outside. Exit interface serial 2/1 is also IPNet outside, and interface Ethernet 3/0 is IPNet inside. Okay, in the same way interface Ethernet 3/1 is IPNet inside. Fine. Now let me enable PAT. So command is what? IPNet inside source match source from route map, and name of route map is primary, right? And translate it into the IP address which is running on interface serial 2/0, and keyword is overload for PAT, right? And let me make one more entry in net table. IPNet inside source route map, name of secondary route map is secondary, and After that, translate it into interface serial 2/1. Whatever IP address is running on this interface, it will translate. Fine, you can verify it. So IP so run and bisection IPNet. Guys, as a CCNA student, you should modify output. Whatever output you want to see, try to see that output only. In real time, if you will run show IP route command in routing on router, right, you will get thousands of route, more than thousands of prefixes, right? So you have to run show IP route OSPF, show IP route BGP, show IP route Eigrp. You have to learn filtering as well, how to filter output. So you can see this is NAT configuration. Okay, now can I ping 8.8.8.8 and source will be E3/0. Yes, now you can see I am able to ping, right? But if my ISP1 bill goes down, again interface serial 2/0 shut down. See, I am still able to ping through ISP2, and when ISP1 will come up, oh, let me run shutdown command. Nah? It will take some time. Oh, it's taking much time. This is GNS. This is not real device. So IP route section 0.0.0. So next hop is static. Where is default route? So track is down. So run section 0.0.0. Why there is no any route in routing table? So IP route. This is problem of GNS3, guys. Don't worry. Let me troubleshoot it. So yes, there is default route. But ISP, okay. Let me down. Table via still 12.2 and remove. So access list. So route map. Have I configured something wrong? Let me configure route map again. No route map primary and no route map secondary. No route map. Guys, this is problem of GNS3 only. Okay, don't worry about that. After that, route map, primary, and sequence number is suppose 20. Clear. Match IP address from list 10 and match interface serial 2/0. Exit route map. After that, name of route map is secondary and sequence number is 10 and match IP address from list 10 and match interface serial 2/1. So route map. So IP route. No set. So IP interface brief exclude unassign. So this loop back. Okay, so this interface is down. Oh my god. How it's possible? Interface serial 2/0. Let me run no shutdown command. So IP interface brief. So yes, now everything is working fine. ऐसा ही हो जाता है, अपने आप इंटरफेस डाउन हो जाता है. लेट मी डाउन this interface. Instead of run no shutdown command on ISP1, by mistaken I have run no shutdown command on ISP2, so both loopback was down. Okay, I think so. So that was problem. So now if you will check on router 1, so IP route, so this is reachable via 11.2. wait, is router will shift it into secondary link, modify next hop IP. So see, my next hop IP is now 22.1.1.2. so ping 8.8.8.8 and source is E0/3, sorry 3/0, right? I am able to ping from my LAN interface, yes, right? And you can trace route as well, trace route 8.8.8. so see, my traffic is going via ISP2 and let me run no shutdown command here, no shut. Okay, so after some time again next hop will modify. Now you can see next hop is 22.2, but now next hop is what, 8.8.8 is reachable via 11.1. Fine. So till now we have discussed IP SLA configuration, route map and default route track with track. Okay, now guys, can I ping 8.8.8 from switch 1? From switch 1 ping 8.8.8.8? No, because there is no any route for 8.8.8 in routing table of the switch. So what we need to do, we need to configure routing. Even you can configure default route toward your edge router as well, right? For that you have to configure default route on both router, right? So I will configure dynamic routing. Let me configure Eigrp and I will redistribute default route of edge router in Eigrp, right? I will distribute default route of Eigrp in RIP. So this router will share that default route with these switches as well. Okay, so let me configure Eigrp. First of all, you can see I am not able to ping 8.8.8 from here now, but I can ping my neighbor 10.1.1.1. Yes, I am able to ping. So let me configure Eigrp. Command will be router Eigrp 10 and say no auto summary and network. Network is 10.1.1.0.0.0.255. Okay, let me configure Eigrp on switch 2 as well. Router Eigrp 10, say no auto summary, and network is 10.1.1.0, wildcard mask is 0.0.255. So IP route. Is there any default route? No. So let me configure Eigrp on router 1 on my edge router. So router Eigrp 100 or 10. Network is 10.1.1.0, wildcard mask is 0.0.255, and say no auto summary and redistribute static. Right now you can check the routing table of switch 1. So IP route, there is default route. Fine. Can I ping 8.8.8 now? Yes, now I can ping. See, I am able to ping. Switch 2 is also able to ping 8.8.8.8. Right? So till now this switch is able to ping 8.8.8 and all traffic is going via which ISP? Via Airtel. We have two ISP, you can see Airtel and Tata. So we can trace route 8.8.8.8. Fine. Traffic is going to 10.1.1.5, then 11.1.1.2. But if my ISP1 bill goes down, or if this link will goes down, automatically my edge router will modify the next hop IP address for that default route. Okay. Now guys, here we need to configure Hsrp. Then these user can also, now you can see PC is not able to ping 8.8.8. PC1 ping 8.8.8.8 because default gateway is what? 192.168.10.100, which is not reachable. So here go to switch 1 and let me configure Hsrp. So IP interface brief exclude unassigned. Okay, so configure terminal interface E0/1 standby. After that group number is suppose 10 and then IP. This is your virtual IP. So virtual IP is 192.168.10.100. Right? And you can set priority as well. Standby group number 10 priority. You can set preempt as well, right? So if this is my primary default gateway, so I will configure preempt here and go to switch 2, configure terminal interface Ethernet 0/1. After that standby and group number is suppose 10 and IP is 192.168.10.100. Fine. And you can track this link as well. You can track this link as well with the help of Hsrp, these two link. Okay, let me do that thing also. First of all, let me show you, am I able to ping 8.8.8 or not? Request timeout, request timeout, request timeout. Oh my god. Oh my god. I am not able to ping because there is no any reachability between this network and this network. So let me advertise 192.168. network in Eigrp. Okay, so go to switch 1, router, Eigrp 10, and network 192.168.10.0 wildcard mask 0.0.255. You can do same thing on this router as well. Router Eigrp 10 and network 192.168.10.0 wildcard mask is 0.0.255. See, I am able to ping. Yes. Can I trace route? So command will be to trace route, trace 8.8.8.8. So my traffic is going to 192.168.10.10, which is my primary default gateway, then 10.1 and then 11.2. So first of all, let me down my default gateway, right? Switch 1, interface E 0/1, say shut down. And now on PC, let me trace route. So again, Hsrp will take some time. Now you can see my default gateway is 10.2. So first hop is 192.168.10.2, then 10.1.1.5 and then 11.1.1.2. Fine. And again, if my switch 1 interface will come up, you can check trace route. Next hop is still 192.168.10.2. So this is Hsrp configuration. You can manipulate these things. So stand by. After that, what? Brief. This interface is standby. Let me change priority. Sorry. Interface Ethernet 0/1. Standby. Group number 10 and priority is 150. Standby 10. You can see now this is active. Go to PC1 and you can trace route. Now which default gateway is active? 10.1. So if your primary default gateway is up, then all traffic will be go via primary link. If primary link is down, then only traffic will go via secondary link, or you can use track as well. So after that you can see track, right? After that, and you can use same track, right? Which track? Which I am using in IPSLA, right? This is same track. So here also you have to create one track. So suppose now my track number is 5. After that, decrement, and whatever value you want to set here. We have discussed this thing in theory, so here I am not going to discuss this thing. Okay, my concern is now see PC is able to ping 8.8.8, ping 8.8.8.8 via primary ISP. But if my primary ISP will goes down, let me down it, still my PC can communicate via secondary link. So it will take some time because of it is GNS3, but in real time it will not take much time. Now you can see this is reply, right? And now if you will trace route, trace 8.8.8.8, so traffic is going via 22.1. let me run nosut command again, nosut on ISP1. So my ISP1 is come up, and now if you will trace route 8.8.8, so yes, it will take some time to give you exact output. This is problem of GNS3. Now you can see. So traffic is going to ISP, going through ISP1, not ISP2. Okay guys, so this is basic configuration, right? In next video maybe I will make one more video on this type of network, how to configure. Here we can configure some more protocol as well, right? So we will discuss about that protocol in next topology. If you like this video, please hit on like button, and if you haven't subscribed my channel, don't forget to subscribe guys. Subscribe this channel and click on bell icon if you want notification whenever I will upload next video. Okay, bye bye. That's all for today. Thanks for watching.